It's been just a year since the launch of the Next Generation Airship project. In that time, the project has gone from an idea to its first flight and the start of production. More than 7,000 people from different countries have already supported it, and the funds raised have made it possible to build a working engineering base, launch production, and enter the real market. The first to take to the skies was the Nova 01 airship, a compact flying laboratory with a volume of 130 cubic meters. It is an exact dynamic replica of the future Nova 2 model, which will have a volume of 2,000 cubic meters and is used to test aerodynamics, control systems, and onboard software. The control system has undergone field testing and already supports 3 modes: manual, remote, and cloud-based. Control is possible using a standard remote, from the office, and even from a tablet. At the same time, assembly has begun on an aeroplane with a volume of 190 cubic meters. It is being built based on the experience of Nova 01, but with improved aerodynamics, 4 main propellers, and a new tail assembly. The first commercial proposals for this aircraft have already been prepared, including for advertising, monitoring, and communications tasks. The Nova 2 airship, with a volume of 2,000 cubic meters, is currently in an active production phase. The gondola blueprints have been completed, and at the moment, its mock-up is underway. All the main components, from the swivel transmission to the tail assembly, are being designed in-house by the team. At the same time, work is underway on the development of a proprietary 300 kilowatt gas turbine power unit. The unit is efficient, silent, and capable of running on various types of fuel, from gas to diesel and liquid coal. It is being developed as a universal energy source for aerial platforms and has already moved into manufacturing individual components. Preparations are underway to launch shell production, materials purchased, equipment prepaid, and facility selected. The first shell is planned to be welded as early as this fall. Launching this production will make it possible to quickly set up mass production of small volume airships and achieve the first profits within this year. At the same time, the next models are being designed. Aircraft with volumes of 8,000 and 35,000 cubic meters. Structural modeling is currently underway, including a rigid hull made from advanced carbon components. Hybrid lift systems are also being developed, which will significantly reduce dependence on ballast and increase payload capacity. And already this fall, the project will be presented at the International Aviation Exhibition Dubai Airshow 2025, alongside the booths of the world's largest companies. Everything that was declared at the beginning of this journey has become a reality within a year. And this is only the beginning. All of this has been made possible thanks to our investors, who, by supporting us, have become full co-owners of the emerging business, for whose products and technologies there is already enormous market demand.
Hello everyone, dear friends. We're back with another exciting webinar, which we regularly hold twice a week with Fedor. We're live again right now.
Once 2 weeks greetings to everyone.
Yes, and today, once again, we will share with you all the very latest news and significant events that have recently happened to us, and we will also talk about airships again. That is our comprehensive plan for today.
Yes, those individuals who have been watching from the very beginning undoubtedly saw the video clip. Today is precisely the day, exactly 1 year ago, when we proudly stood on stage at the International Financial Center in Moscow, situated on the riverbank, and officially announced the launch of the project, specifically the pre-launch phase. If you haven't watched it, rewind to the beginning and check out the video. It's a concise summary of what has happened over the past year. In reality, AERONOVA hasn't been around for just a year. AERONOVA was actually formed, as we figured for ourselves, sometime around October, basically when we moved into the office and really started working. But as for the project itself, yes, it's been a year since it began, and that's what started it all, including you. Congratulations to everyone, of course.
We can do a brief recap of what we've accomplished over the past year and also over the last 2 weeks.
The comprehensive results are summarized in the video. As for what we've successfully accomplished in the past 2 weeks, I think we can thoroughly discuss that and our future plans as well.
Well, let's start with that then.
Go ahead, please.
Alright, let's start with the most incredibly interesting and truly exciting news, which seems to be finally and officially confirmed. Yesterday you personally went to the airfield to check out the brand new one, so please tell us all about it. In general, my dear friends, for those of you who have been diligently following us for quite a while,
for those who have started following us recently, we've been looking for an airfield to purchase, and it looks like we've found one. Today we received the final documents. According to these documents, everything is in order. We need an airfield. As a company engaged in the production and subsequent operation of aviation transport vehicles, we need a place to conduct test flights, trials, and so on. Many people are well aware that we used to fly at Novinky, and now we are currently flying in Voskresensk. Of course, we absolutely have to share the available airspace with others who also fly at that particular airfield, and we also pay rent for the hangars and so on. It was truly great, a very good temporary solution, and flying there was absolutely awesome. But now we will undoubtedly need to fly more and more often. That is the very first and most important thing. And secondly, we haven't yet found a sufficiently large space for rent for the next airship, Nova 2, that's as easily and readily available as snapping your fingers. And the necessary facility needs to be constructed both on a temporary basis and then permanently. This crucial decision is still being actively decided, and naturally it's certainly preferable to build it on our very own land, specifically on the project's dedicated land, in order to fully capitalize on its potential, and so the project itself has something truly tangible, something unequivocally of its very own behind it. Well, that's obviously the case. That's precisely why we were diligently looking for suitable airfields, and we successfully found one.
Although it wasn't an easy task, even though there are quite a few airfields, you showed the map yourself.
Yes, if you're interested, you can just type airfield map of Russia into Google or Yandex, and the first link will give you a map showing all the active airfields. So you can click on these airfields, look at the descriptions of the runways, and of course see their coordinates, what radio frequency they use, who the flight director is, who the administrator is. This is publicly available information, but of course it is only for civilian airfields. And one of these specific airfields, clearly shown on the detailed map, will very soon be entirely ours and yours, naturally, for everyone to utilize. Everything is definitively supposed to happen in August. Right now, we're at a particularly interesting and crucial stage. We are actively starting to work and collaborate closely with the administration of the specific district where this project is precisely located, as well as engaging with various essential organizations and key stakeholders with whom we absolutely need to coordinate and align our efforts for successful implementation.
Basically, we're setting up all these processes, and it seems like congratulations are in order for the discovery as well.
We can celebrate the initial discovery, but we'll truly celebrate the actual acquisition once we actually acquire it, when we formally sign the contract and make the very first payment. The payment will be in convenient installments, hallelujah. We successfully managed to arrange that because it's just not practically possible to pay the entire amount all at once. Now would be the perfect time for Medvedev's famous phrase, "But you hang in there?" Right. But overall, everything is coming together wonderfully. Our shell production is just about ready, and with this shell production, we'll make the shell. The assembly of the Nova 2, and this Nova 2 assembly will already take place at our own airfield. That's truly awesome, I genuinely think, and basically, just today, this significant information became much more solid and concrete, and today actually marks a full year for the project's existence and development.
Pretty symbolic, isn't it?
Yes.
And if you remember, perhaps you could kindly share some key characteristics, like maybe some specific airfield details, precisely how many hectares it currently covers, what essential facilities have already been built, what we still need to accomplish, if we can share that important information right now.
Yes, there's a small hangar located there where both the Nova 01 and the accompanying aeroplane can comfortably fit. Actually, both of them can indeed fit inside. Well, obviously there's a substantial runway there, one made of concrete and another, a more rustic one, of dirt, and there are also several utility buildings, a charming small house, and a garage that's more like a simple shed. Yes, for the tractor. There's a tractor there because the whole field needs to be mowed constantly and kept in shape so it doesn't get overgrown. The airfield itself is over 1 kilometer long and a bit less than 1 kilometer wide. Basically, most airfields are just long strips, runways, well, a strip somewhere in the forest. Sure, you can take off and land on it like an airplane, but we don't need to do it like an airplane. We're going to have circles. Takeoff circles, basically, where airships will be maneuvering around low, large mooring masts. So we don't need a runway, but ideally a field, preferably a square one. So more or less, we were looking for a place with that kind of shape and found this airfield. Like I said, it's a little over 1 kilometer long and less than 1 kilometer wide, so it's basically a rectangle. Yes, it's oval shaped, no trees, nothing, just flat land, everything is absolutely perfect. It's in a picturesque location. I think all of you will definitely end up there, and we'll watch them fly many times, celebrating the launch of each new machine. We'll hold all sorts of events there, conferences, what else? Various gatherings, yes, birthdays, and so on.
As I understand it, there's plenty of space there, so besides the one hangar that's already there, which can fit the Novaya 01 and the aeroplane, we'll be able to build more next to it, right?
It's necessary. We absolutely need to start already in August. The deal will certainly go through, and it's truly best to begin in August because even if it's a temporary structure, what I specifically call a pneumatic hangar, you still really need to prepare the essential foundation for it, pour the concrete slab, and bring in the necessary electricity. In general, there's a lot of different operational work to be done, and it all needs to be carefully coordinated with the production framework in terms of precise timing and overall budget and everything else. The comprehensive list of expenses is, of course, actively competing for the top spot, specifically generators and also engines. The engines were paid for halfway, and now they're about to be shipped, and the second half of the payment needs to be completed. Some of the machines have been paid for in advance. In general, there's a lot to do, and we need to start all of it right now, this month. And if everything goes well, all these subsequent steps should naturally follow one after another in a seamless progression. When the shell is completely ready, there should be a designated place that is meticulously prepared so that we can effectively outline it and then have it conditionally and thoroughly accepted by our internal quality control department. And then we'll start assembling the airship right there.
By the way, friends, given the significantly increased opportunities and the substantial expenses that AERONOVA is currently facing, SOLARGROUP has thoughtfully launched a comprehensive series of attractive promotions starting precisely from August 4th to actively encourage additional and valuable investment. I recommend everyone to log into your personal account and go to the promotion section, where they are described in great detail. I'll just briefly go over them. The very first promotion is for all investors in both projects. The promotion is that for every $100 invested in any of the projects, you will receive a 10% discount. It's important that the payment amount is $100 or more, and for every $100 you receive, you get a 10% discount. And the second promotion is for all partners called the Big Race. It runs from August 4th to November 4th, so it will last a full 3 months. Here, the company will generously award significant cash prizes if you successfully upgrade your partner status, or if your valued partners in your very first line also manage to upgrade their partner status. You can find more details about all of this in your personal account under the promotion section. So be sure to check it out, participate, and let's encourage, so to speak, the influx of new people and investments, which we so desperately need right now. So I hope I've covered everything here.
Regarding the upcoming partner race, we are just about to commence the exciting partner race at the airfield location.
Yes, we will certainly get to that as well, but let us briefly touch on this topic now too.
Tomorrow, for the first time, we've had small groups come before, as you might have seen in the video in the news section, but those visits were more spontaneous and informal. Tomorrow, the very first organized group of interested investors and deeply concerned individuals will be coming to us in Voskresensk. We'll be holding public demonstration flights and personally introducing them to the impressive equipment in person. It's a truly very fascinating and captivating spectacle. Of course, we want to share this incredible experience with everyone when the magnificent airship is finally flying.
We'll be bringing people in several groups. We're starting this Friday. I think everyone who wants to join...
I don't know the exact schedule when it is. Every Friday.
But again, everything will depend a lot on the current weather conditions as always.
Well, naturally. But for now, it looks like it'll be every Friday. So look out for information. I hope it will appear in the general groups and chats about how to sign up, get in, and see it. In short, just know, it all starts tomorrow. We plan to head out tomorrow already.
We'll definitely do a report, some filming. All the participants who go there will be sure to share their impressions and their first emotions.
If anyone here at this insightful webinar is going tomorrow, please write in the comments, "I'm definitely going," so we know who the truly lucky ones are that will be the very first to see all this amazing content. Or write, "I really want to," so we can get a much better sense of how often we should organize such engaging and valuable events.
Yes, let's also discuss what other interesting developments have occurred over these past 2 weeks. For an entire week, specifically 5 full working days, all of our engineers have been actively undergoing comprehensive training on the T-Flex program. Could we find out in more detail what exactly this program entails, why such in-depth knowledge is genuinely needed, and why this training is taking place right now?
The first airships being developed here right now are, for the most part, like flying laboratories, or rather experimental prototypes, mock-ups and so on, designed for quickly testing out various solutions. This is better, this is worse, this is something new, it worked, it didn't work. In other words, it's a rapid evolutionary process. It could certainly be done, and we meticulously organized it in a kind of partial, I'd call it, in-house IT department, where some dedicated people work in SolidWorks, some in Compass, some in NX, and others in CATIA. Basically, you name it, we've probably got it. We've
All sorts of blenders too.
and in 3D Max, basically in anything and everything you might typically use for design and visualization. However, when it comes to creating equipment for serial production and subsequently certifying it, it becomes abundantly clear that you cannot simply approach these tasks in a haphazard or sloppy manner. Precision and meticulous attention to detail are absolutely essential for successful outcomes. And that's actually being widely practiced in our country right now, because everyone clearly understands that since the software is foreign and the foreign companies have unfortunately left, there are some viable Russian alternatives, some back and forth, and this situation is constantly evolving. Basically, these companies have been operating for a long time, and the processes have been, you could say, evolutionary, from drafting tables through the first versions of AutoCAD, then to some Siemens centers, and now they're transitioning to some new systems. So, since we are at the very beginning of this process, we can actually commence the process of creating serial production devices within a unified digital environment.
Create it correctly.
Yes, and in general, there are all sorts of comprehensive and meticulously developed GOST standards that rigorously regulate the entire complex process of creating and manufacturing aviation equipment, as well as advanced space technology. Civilian, military, and so on, and you can follow all these GOST standards even when designing on paper. There are certain procedures and sequences there. Basically, from the very inception and initial planning of the project, research and development, R&D, must be started correctly and with proper foundational steps. That is to say, there should be an official order and a clear directive. An order like, for example, to submit proposals, to meticulously draft the detailed technical specifications, to officially launch the crucial R&D. In general, all of this important work should be carefully carried out step by step. Naturally, everything should also be properly documented. And so T-Flex has integrated all these processes into its software, starting from the standards, let's say the GOSTs, for initiating R&D, engineering development, and moving towards mass production. And ending with this CAD system, where you do solid modeling or create a 2D drawing, although 2D is no longer necessary since it automatically converts from the solid model according to ESKD standards. Come the calculations, the so-called process sheets and post-processing programs for CNC machines. And we do all of this together with a CRM system where the entire organizational structure of the company is managed, along with all tasks and plans. Responsible oversight. Naturally, access controls, storage of the entire product architecture. In other words, the entire enterprise cycle is integrated into a single piece of software as much as possible. And this software isn't just convenient, it's built according to standard requirements like GOST, ESKD, and so on. So, in a way, it's like a checklist. If you work with this software, you're basically doing everything 99% correctly.
So is it also a kind of CRM system in a way?
Including a CRM, yes. In fact, it even serves as a kind of guide for the most part. Instead of everyone, well, of course, many people already know all this, they read it and so on. But overall, when you work in such a unified environment, it's much easier. And yes, training is underway now. The training is divided into several stages. Right now, the first and foundational stage is, of course, the comprehensive CAD, CAM, and CAE systems. This entire process is fundamentally about detailed modeling. Yes, it's specifically about precise modeling, intricate calculations, meticulously creating the overall product architecture, carefully creating complex assemblies, efficiently managing various versions of these critical assemblies, and so on. For several months now, our dedicated engineers have been diligently studying T-Flex on their own initiative. So what we did was, well, we have, let's say, an electronic model archivist. This is the dedicated person who meticulously receives all the detailed drawings from various programs. He was definitely already working extensively in T-Flex and was diligently creating the main assembly within T-Flex. Some people were already starting to, well, gradually transition. Some people were already starting to, well, gradually transition. Some were moving, so to speak, towards solid modeling in T-Flex. Others towards certain calculations, and so on. To put it simply, everyone clicked around, ran into issues, some understood things, some didn't, but everyone gained some experience, and now we're quickly going through the basics again, covering any unclear points one more time. Well, you could perform the same functions either by finding the right buttons or the old-fashioned way, by manually tweaking and drawing, and that stage is now behind us. Introducing assembly is important, including version control and so on. And this is the learning cycle. Now they'll study for a week, then after a couple of months they'll apply this knowledge. And by the very end of this current year, we absolutely need to achieve full and complete operation of the entire PLM system, along with the crucial CRM and virtually everything else. For the time being, our existing CRM is still somewhat residing in Kaizen, but rest assured, everything will be migrated there, and this transition is actually quite necessary and indeed essential. As I previously mentioned concerning the vital aspect of certifications, devices, specifically those commencing from the compact and portable size of the Novo 8 model, will unequivocally undergo and successfully obtain type certification. Furthermore, to officially and formally launch this significant research and development initiative, our clear intention is to execute this process specifically and exclusively through the established T-Flex platform. Once we have it implemented and all processes are running digitally. Interestingly, by the way, this probably won't be the first, but it will definitely be the first airship R&D project conceived in a digital environment, 100%. By the way, as I understand it, this platform is of Russian origin. Yes, there is indeed a university called Stankin. Graduates from Stankin themselves created it. It appeared a very long time ago, around the same period as AutoCAD was initially emerging, but it evolved in its own unique way, and AutoCAD also evolved in its own distinct way. T-Flex has really powerful parameterization. It's a very convenient feature where you can link all the dimensions using formulas, and you don't have to rebuild the entire assembly manually. You just adjust the dimension, hit recalculate, and everything updates automatically. It's very convenient. Back in the day, that was their main competitive edge. They had the strongest parameterization when everyone else was just starting to implement it. And now they've fully shifted towards enterprise management. It's convenient.
Plus, as I understand it, this platform also allows you to secure the exchange of documents between employees.
Well, to organize it, yes, and to secure it as well.
I think we can now move on to the next important question. We've had a considerable number of field trips, I know, for extensive training at the airfield. You personally flew on the Nova 01 airship. What significant changes or new developments do we have there? What exactly did you test and observe?
Did you thoroughly check and test it? Did we indeed have a mooring system in place? Yes, we did perform the mooring, and for the time being everything was meticulously done manually as well. Well, there's the intricate design of this specific mooring lock, which is also entirely our own proprietary development, conceived and engineered completely in-house. Naturally, everything involved is entirely our own innovative development. There was a significant dilemma, or rather, a rather extensive discussion, you could certainly say. There were some quite detailed discussions about whether it was even technically possible for an airship to reach a very low mooring point at all. Well, because usually an airship is caught by hand, or by some kind of mobile machine, basically something that has a bit more freedom than the airship aiming at it. Still, a person would somehow dock everything together by hand, and here there's just some kind of stump. So a number of mechanisms were devised, and for now we've chosen the one that seems most successful to us. It's when there are simply certain guides. There's quite a large distance here, and a small stump. Even if the stump comes here along these guides, it comes to the lock and latches on. Basically, the airship, of course, needs to determine from which side the pilot or autopilot is, from which direction the wind is blowing, and then face into the wind. After landing, it should roll forward a little and latch onto it. You can land almost vertically there, but you still absolutely need to move either the airship itself or the entire mechanism forward a little bit more to truly make the capture happen effectively. For now, we carefully move the airship itself steadily forward, and it's truly quite an amazing and impressive sight. The very first time we attempted this maneuver, it unfortunately did not work as intended, but on the second diligent try, obviously in a precise manual mode, we calmly and expertly landed right onto that designated stump, and the airship successfully docked itself even without the guiding mechanisms. So there was originally a rather small mechanism located there, measuring about 15 precise centimeters, consisting of just these little essential guides. Right here you can clearly see a robust latch, and, well, once again, this is a meticulously crafted scale model of precisely what will be permanently installed on the Nova 2. And there should also be these whiskers here, approximately this size, with roughly this extensive span, to accurately simulate what will be on the Nova 2. So without these whiskers, just with this small intricate mechanism, the very first time it moves, it goes, and then bam. We carefully turned the propellers backward, moved back, the stern thruster turned a little bit, propellers forward, and we got hooked. In automatic mode, I think it will do all this even more precisely. Right now, we've just reached this automatic stage. There's a ton of interesting stuff, both in the software, at the boundary between software and hardware, and with the hardware itself. Just recently, another significant artifact popped up. We have a crucial main power line interrupter, which reliably supplies electrical power to the primary propulsion engines, the entire tail assembly, and the powerful tail thruster. Dio no tosto de castane. There are separate batteries located there. One is entirely dedicated to all of that, and the other specifically powers the computer and the VGS system, which in turn runs the cooling fan and other essential auxiliary systems. So when the relay interrupter disconnects the main power supply and then subsequently reconnects it at the precise moment of reconnection, these electrical circuits are completely isolated from each other. So the secondary one for the computer, which is 48 volts, and the powerful 24-volt one, which is basically the onboard battery, are not connected in any way whatsoever. But when the interrupter on the 48-volt line is triggered and turns on, our flight controller stops communicating with the computer entirely. That's an interesting and quite unusual artifact. Obviously, there's probably some kind of significant surge or something similar that absolutely needs to be effectively shielded, and so on and so forth. Those are indeed the very first thoughts that immediately come to mind, but it seems like just yesterday we figured it all out, and a lot of these perplexing little things just keep persistently popping up.
That's exactly why Novo 01 was created, to detect visual artifacts.
What I'm trying to say is, once we press the button and it successfully docks, once we meticulously fix all these minor little things and completely stop worrying about them, that's probably going to happen at any given moment now. Because everything is already working, everything is already clear, but still, during the testing process, all sorts of little things come up. We keep fixing them, removing them, resolving them. Next week at least, I already expect that we'll press the button and it will itself. Using the video cameras, we will precisely determine the exact point. We'll just stand there like this, completely still, and it will automatically grab onto it and firmly latch on by itself. That will indeed be a significant victory in a very real way. Yes, that will absolutely be. So to speak, this marks the conditional completion of the initial and very first testing cycle. Yes, then comes the subsequent and significantly larger, more comprehensive and indeed more interesting second testing cycle. We will delve into the specifics and discuss that in a bit more detail later on.
By the way, I really like the solution where the mooring point is not located on the very nose of the airship itself, but rather on the gondola, which significantly reduces its weather vaning radius. In other words, it effectively saves space.
Yes, fortunately, there's plenty of space in Russia. This kind of solution just seemed obvious, really. And besides, when the airship is moored by the nose and is weather vaning, if it's a small, rigid type airship where you can, in theory, walk right through the nose section along the hull, that's one thing. But if it's something smaller, where the gondola is separate, then this gondola, which rotates in a circle as it weather vanes, makes it much harder to run after it to load or unload it yourself. Naturally, it's easier when it's attached by the gondola and the gondola stays in place. Yes, it does turn and so on, but during loading and unloading, the airship can be fixed in position. And firstly, the wind doesn't constantly shift back and forth, and secondly, the tail steering device can easily stabilize it a bit.
Overall, everything is much simpler and significantly more convenient. Plus, there was also a special platform. I saw it, though I happened to be absent that particular day. But I saw that they meticulously made a truly special platform for the
landing gear. Yes, it's kind of a simulation of what will be specifically made for the upcoming Nova 2 as well. I think I already mentioned this in the last webinar, or at least I certainly should have mentioned it to you. I was explaining that basically, because it's securely attached to the lower mooring point while the airship itself is positioned above, and there's a significant side gust, there's quite a considerably large lever arm here, and the airship naturally tilts and consequently puts pressure on one of its wheels.
load on the chassis.
Yes, because the landing gear has two wheels, and the load, which is at its maximum under the maximum calculated conditions, in general up to 15 meters per second, we can weather vane at the lower mooring point on a small airship, specifically on one like the Nova 2, one of a Donadu and a Dosandotandobwe. It's a bit easier with larger ones. Their gondolas are positioned closer to the nose due to mass balancing, so weather vaning becomes easier. In general, on the Nova 2, with such a side gust, the load on a single wheel can reach up to 1 ton. If it's just regular soil, it can simply get bogged down. Over time? Yes, well, after an hour, 2 or 3 of this happening.
Plus, there's also moisture, and the soil is quite damp.
Yes, and that's precisely why you need to make a stable platform directly under the wheel. It's actually quite small in its overall dimensions. On the Nova 2, the wheel will be approximately 4 meters, much like a strip foundation. Or you can also lay down a durable metal sheet, so that's how it will be implemented on the Nova 2. So that's why we did the same thing on the Nova 01.
You could say this is our primary runway, which is absolutely necessary for airships, that's all. Just a small, unassuming patch of ground, nothing more.
The site ends up being a mooring and maneuvering area. Still, well, actually it depends on the mooring mast. For example, when you have a large tall mooring mast, for safety reasons, and according to all regulations, the airship needs to be moved quite far away. If the wind picks up, you could damage the envelope during takeoff. And as for the mooring point, you truly don't need to move very far away from it at all. You simply need to detach, and that's absolutely it. You can then ascend vertically. So yes, actually I hadn't really thought about it in this way before, but you could certainly call it a dedicated takeoff and landing pad, especially since you don't actually need to fly away from it in any significant manner. In fact, nothing quite like this has ever truly happened before, especially if we trust the seasoned experts. The airship specialist Muzikevich clearly states that no airship has ever successfully landed or taken off from a low mooring point like this, where everything is so incredibly easy and remarkably simple. For some inexplicable reason, people were always inventing all sorts of intricate and unnecessary complications, incredible and elaborate mechanisms, extra mechanization devices, and extensive automation, almost as if they were putting things on predetermined rails or something similar. Everything absolutely had to be complicated, novel, and entirely new.
Well, yes, they came up with all that.
It works.
And besides all that, ongoing flight tests are constantly being conducted, and important information is being gathered for training. That's absolutely true.
Actually, all the algorithms have already been written and the data has been collected.
The main ones that were originally included.
Yes, everything is already perfectly and unequivocally clear. Now, regarding the flights, What's being meticulously developed are the sophisticated algorithms and the underlying logic for precise near-Earth operations, all functioning in a completely and seamlessly fully automatic mode. Basically, there's a remote operator who opens a tablet and then sees that the airship is located somewhere on the map, on some particular map, let's say, and can clearly see precisely where it might be situated at all times, what state it might be in, whether it's moored at the lower point, at the nose point, or to some additional device, or if it's inside a hangar, and from each of these situations, further scenarios develop for what will happen next. And right now, these scenarios are being developed both from a logical standpoint, simply as a logical sequence of what will happen next, as well as with the specific hardware and software versions currently in use, what additional essential devices and other crucial components the airship should possess and integrate in order for this complex interaction to effectively take place in a fully automatic and seamless operational mode. This comprehensive process is precisely the second critical stage of extensive testing, or more accurately, the second significant phase of development and evaluation.
Well, that's what we have planned for the near future, the plans, goals, and objectives that we intended to pursue.
Right now, everything is happening in a somewhat semi-manual mode, and as for fully automatic operation, it's abundantly clear that all of this will be implemented in its complete and full glory on the Nova 2, but to a certain advanced stage, I think we will definitely achieve that on the...
Regarding Nova 01, we also previously mentioned that in the very near future we are indeed planning for the development and implementation of the aeroplane. Could you please provide an update on what specific stage of development it is currently at right now?
Today we had a significant local business trip to the primary shell production site. Everything is truly great. Everything is perfectly cool. The intricate shell is actively being created, being meticulously welded. The very first one was carefully glued onto the Nova 01 spacecraft, and now this particular one is currently being welded with powerful high-frequency electrical currents, all under the direct and careful supervision of the original author. In general, we went out there, Dmitry Sergeyevich Kamel, with a thorough inspection and complete documentation, everything precisely as it should be. The designer is consistently present at the production site, meticulously making sure everything is done correctly, strictly according to his detailed drawings, precise designs, and specific technical requirements, and so on. On this side, everything is diligently being done. Control systems are being carefully assembled, and essential materials are being promptly purchased.
So, does that truly mean we'll be able to clearly see the very first steps of assembling our new aeroplane in the very near future?
Yes. No, I think yes, but of course we will certainly see how things unfold, and there will undoubtedly be extensive footage, numerous compelling videos, and in general, I want to address all our dear viewers and dedicated project participants. I understand you currently have little information about what an AEROLÖT is, how it differs from a non-AEROLÖT, its appearance, why it's created, and what it actually is. There are truly tons and tons of different questions, and of course, it's now time for us to open a separate and dedicated section in our content about these fascinating airships, to make videos and perhaps even write detailed articles explaining precisely why we've moved in this particular direction. If anyone possesses innovative directorial ideas or exceptional script writing skills, we are eagerly awaiting your valuable suggestions and creative input on precisely how we can effectively and successfully break into the fascinating and expansive content branch specifically dedicated to the captivating world of aeroplanes and aviation. But overall, yes, we are indeed ready. The essential foundation has already been laid, both in terms of design and production. We have many things to show and compelling stories to tell, and with your valuable help, or even without it, we will be showing and telling them very soon. So let us now get started. Basically,
where exactly will we be able to effectively use or prominently see this magnificent aeroplane? Is it currently being meticulously prepared for some significant and exciting trip in the very near future, or perhaps for an important and impressive demonstration that will showcase its remarkable capabilities?
Are you hinting at November, specifically at the 11th month of the year, at the vibrant and bustling city of Dubai? Yes, indeed. Are we truly planning to take this exciting venture there, to that incredible destination, or not after all? No, absolutely not. So, regarding the highly anticipated Dubai exhibition, first and foremost, we are definitely going. Of course, we are absolutely going to be there, participating in this significant event. The link has already been widely shared. I sincerely hope that those who checked it out found precisely where AERONOVA is located. We have a substantially large 6-meter booth there, positioned right next to Boeing Ventures, but still, we are also Ventures too. Nearby there are investors, a lounge area where presentations and all sorts of things will take place, and that's where we've applied to participate. In general, we've already prepared the technical specifications for the booth for the contractor and are handing them over, and we've come up with the booth concept. We really wanted to hang the aeroplane above the entire booth, but the thing is the aeroplane is 19 meters long, while the booth is only 6 by 6 meters. The ceiling is really high though, so we thought, what's the difference? It's light, it's safe, we can easily hang it up, there's no problem with that. But no, the very strict requirements of the Expo Center are that absolutely nothing, not even a single component, can extend beyond the designated perimeter of the booth, and the large aeroplane simply does not fit within that confined space there. Right now, we're negotiating to have it placed outside, where the airplanes and other equipment will be located. Maybe they'll allow it, maybe they won't. We should have arranged this earlier, much earlier. With the booth, it's clear. There was a spot, we took it, but with the outdoor area, everything is still up in the air. As for the essential documents required for the device itself, of course, it is currently experimental, but it is also certified. And there is the significant matter of its delivery. If you possess this particular flying vehicle, then bringing it into the territory. If it were merely a mock-up, for instance, simply hanging above our designated booth, that would be one thing entirely. However, when we specifically want it positioned within the area where the equipment is prominently displayed, that presents a considerably different situation and set of logistical challenges. There's a small chance that we'll set it up outside, and perhaps even demonstrate precisely how it actually flies, which would be really quite cool, of course, but to fully answer the pressing question of whether we'll be showing it there, at the booth, definitely not. Inside the expansive pavilion at our dedicated booth, we'll be meticulously making a detailed model of the impressive airship. Yes, we certainly have a clear idea. Most likely it will be the Nova 35. So there you have it. We've just openly told the entire world. It's been a full year, you know, since the ambitious project initially started. November will precisely mark a full year, roughly, since the groundbreaking AERONOVA project officially began, and everyone is already incredibly curious. What exactly is the Nova 35? What is this innovative rigid airship concept? And where is the whole fascinating field of airship development truly headed in the coming decades?
It would be truly great to formally announce this significant development at major world exhibitions. It makes perfect sense to specifically start with rigid airships, or at the very least to clearly demonstrate that we are indeed aiming for airships of this particular type.
Yes, that's why the model will be a rigid structure airship, and everything will be meticulously built around that foundational concept, with plenty of other truly pleasant surprises and engaging interactive features. Yes, we'll talk more about all of this a bit later, but yes, we'd like the aeroplane to be there and flying. Most likely we'll make it happen, but it will be flying here, and everyone will be able to see it perfectly well, and there will be videos about it shown there. There's not much time left. It's already August, then September, October, 3 months, even less, considering that August is vacation season. And many of us are on vacation, as well as people at related companies we depend on. They're all on vacation too. And with the engine, it just so happened that the engine for the Nova 2, vacations and the intense oppressive heat in that particular European country, where they're coming from, all perfectly and precisely coincided, creating a truly unique and challenging situation.
So things have indeed gotten shifted, and yes, there is not much time truly remaining. We also very much wanted to touch upon the significant topic of the stratosphere. We've quite often heard numerous questions about precisely why we don't show how the development process is actually going, how the various launches are meticulously carried out, and it certainly seems like we have something rather exciting planned.
Something is in the works, and I want to remind you that we are working on the stratosphere, but we devote much less time to it than to the airships, because obviously airships are our main focus, and the stratosphere, even though it involves Archimedes' principle, but these are somewhat more distant prospects, a bit more complex overall, but significant work is actively underway. And in the very near future, we will certainly have what I would call another important attempt at carefully carrying out a long-duration, extended drifting launch. Since that initial launch, the one we actively showcased and extensively talked about, the truly long-duration drifting one, there have, of course, been numerous subsequent launches up to today, but these were primarily peak launches. That is to say, the device would typically take off, reach a certain maximum altitude, and then promptly land. Mostly, these were technical and technological tests, factory trials of various solutions, valves, sensors, new onboard equipment again, the docking system, the payload rescue system, and all sorts of coordinate measurement systems. There haven't been any truly long-duration drifts, and now the very next long-duration drift is about to happen. It will be here and now, most likely this coming weekend or next week, quite soon. Everything depends on the weather conditions, but the launch is already scheduled, and this launch is different from the previous one. If the primary goal of the previous launch was to successfully enter a stratospheric current and then remain there for as long as humanly possible, ideally completing a full round-the-world journey, this particular time the launch is quite a bit different. The stratospheric vortex, of course, has completely dissipated. This is a well-understood and entirely seasonal phenomenon that occurs annually, and now for those dedicated individuals who diligently follow the intricate dynamics of the stratosphere and still have that essential link meticulously bookmarked where you can precisely check the prevailing wind patterns across the entire planet at various distinct altitudes. They can check the prevailing weather over Russia, and at different distinct altitudes you'll see that the wind blows in one direction, then there's a noticeable and brief pause, and then the wind blows in the opposite direction. The current task is to effectively change these atmospheric flows by precisely adjusting altitude levels.
In other words, to learn, so to speak, to swim in these currents in a controlled and predictable way?
Practically in a controlled way, definitely predictably, using a mathematical model with all the verification and so on. As for changing altitude, we'll do that by heating, during the day and at night. So far, with both the long-duration drift and the small, precise launches, we have thoroughly verified the comprehensive models of thermal heating, specifically both the significant heat coming from the ground and the substantial heat coming directly from the sun, and so on. This comprehensive verification has a truly significant and measurable impact on the change in the altitude of the device, on the heating of the contained helium, and so forth. And now, we have already successfully created a fairly accurate and comprehensive mathematical model. So, by simply and properly, let's say, filling the lifting envelope, we can then pour in the precisely required amount of helium. And so, the system consists of several high-pressure cylinders. Well, not cylinders, they're also envelopes, but in general, if the upper envelope, yes, not ballasted, becomes ballast at a certain point, yes, that's correct. The upper envelope is at zero pressure, meaning the pressure inside and outside is precisely the same, so these particular envelopes are specifically designed so that the gas contained within them expands, and at some point, bam, the volume stops changing and the device stops rising. In other words, it completely loses its buoyancy.
It stabilizes at a certain calculated altitude?
Yes, and if you properly and completely fill the upper envelope and a series of such envelopes, then according to the established temperature model, we can quite accurately predict to what altitude it will descend when cooled and to what altitude it will rise when heated. And so, first of all, this particular launch meticulously verifies the mathematical model. It could potentially become an epic fail, yes, but the underlying model is quite accurate and robust. And overall, we are already sufficiently confident enough that we can make it publicly available. And let's all watch together to see whether it actually works or not. It really should work. So during the daytime, it will rise due to significant heating and then drift in one particular current, and at night, it will cool down, descend to a certain lower altitude, and then drift in another distinct current. And it's as if our mathematical model will accurately predict in which specific zone it will circulate.
So we already have some understanding of how it will fly, and now we need to, let's say, confirm all of this in practice.
Yes, and in fact with truly minimal effort, basically without any significant energy expenditure whatsoever, we are able to effortlessly suspend the device, allowing it to occupy a specific and designated area with it, and it consistently and reliably remains precisely there, maintaining its position without any further intervention. Roughly speaking, it's a kind of stratospheric satellite that hovers over a single point, at least in the first approximation. Of course, going forward, and even now during peak launches, Various systems are being tested that will, so to speak, forcibly change its altitude, like ballast systems and all sorts of others. I won't go into extensive details for now. Later we'll thoroughly study together precisely how it actually works. In other words, these advanced systems are already being rigorously tested where we can precisely change the altitude on command directly from the ground. And this is a conditionally free system. It's the simplest possible solution, which we absolutely have to take into account for controlled flight anyway. There's simply no way around it. This is a pure experiment, a fundamental test.
So we'll film everything and show it to you?
Yes, most likely. We'll also be doing some kind of live update, showing precisely where it is and what's currently happening with it right now. The launches are being postponed a bit. Actually, we were originally supposed to launch it on Tuesday. Leave on Tuesday and then launch on Wednesday. Then it was moved from Wednesday to Friday and subsequently from Friday to Sunday. But it's not us making these particular changes. It's Rosaviatia, so to speak. They inform us of the exact launch point, the specific location where we can launch from. We meticulously calculate a mathematical model to precisely determine the area where it will fly. They carefully review whether that's acceptable or not, and then they proceed to move the launch point. We're counting again. Basically, it all really depends significantly on the prevailing wind conditions, on the overall weather situation, and also, of course, on Rosaviatia. So, more or less, they've already moved us to a location somewhere near Kirov, and most likely, everything is currently being settled so that this upcoming weekend, or perhaps during the course of the next work week, everything will indeed happen. So, please stay tuned for further updates.
I think we'll remind you in separate, dedicated videos about precisely what the stratosphere is, why it's so incredibly interesting, and why it's truly needed, because many people don't really understand its fundamental importance. In fact, even though we released a whole comprehensive documentary film and talked a great deal about the stratosphere when we initially launched our innovative device, we still frequently get numerous questions about it. Yes, there isn't a complete understanding of the topic at present, so we will endeavor to cover the subject matter in significantly more detail. Actually, that's pretty much all the main news and important updates I currently have to share, so we can now smoothly move on to addressing your pressing questions. Let's proceed in this manner. I have the very first question right here. How high and precisely how much payload will the airship ultimately be able to carry?
I think this question is actually about the aeroplane, because we've already talked a lot about the Nova 01. Everyone knows about it. But please clarify your questions, since we don't have the context here. If you included more context in your question, we could answer it more precisely. I hope by payload, you mean the general useful load. Airships are essentially peaceful transport. For the most part, they're not intended to carry anything military. Well, the AEROLÖT will have a payload of 50 kilograms, at least the first one. The AEROLÖT we're developing is essentially the same as the Nova 01, but in the context of the Nova 2. The AEROLÖT 01 will carry 50 kilo. If you're asking about the Nova 2, that's 500 kilos or more. If you're asking about the AEROLÖT 2, that's tons or more.
Actually, you gave a pretty detailed description of all the characteristics of the planned models in the previous webinar. So if you haven't watched it, I highly recommend checking it out. Fedor explained everything in detail.
That webinar was in a lecture format, more like what we're building and where we are right now. If you haven't watched it, it's not like this, with us sitting at a table. In that one, I'm drawing all the devices and their features by hand in the background and generally explaining where everything is located. Check it out if you haven't seen it.
Yeah, it was the Thursday before last, so the previous one, skipping one. Alright, let us now move on to the next important question. How exactly are you going to handle the refueling process with either hydrogen or helium?
Well, airships are of course filled with helium. As for stratospheric probes, it's quite likely that we'll soon start trying hydrogen. Stratospheric airships will definitely be filled with hydrogen because their volumes are incredibly huge, and the envelopes most likely will be made of very light and durable materials, allowing for their immense size and operational efficiency. In general, there are different approaches. One effective approach is to utilize disposable envelopes for stratospheric airships. These envelopes don't cost much, and after, say, approximately 3 to 4 months of continuous operation in the harsh stratosphere, the envelope is carefully detached, the gas is safely released, and then all the essential systems land gracefully like a glider, while the envelope simply drifts away, and that's essentially that. This is one of the possible approaches, and in this scenario, hydrogen is definitely used, because losing that much helium would be unreasonable. And as for those airships that will be flying close to the ground, everything will definitely use safe gases, definitely helium. Great. Will the airship be visible on radars? Well, it depends on the type of radar. Yes, it will be visible. What are you interested in? You can make an airship as incredibly stealthy as possible because its entire physical body is basically nothing, soft, pliable, and inherently small, so there's not much substantial material for the radar to effectively pick up. Well, naturally, there are internal batteries and powerful engines that generate significant heat, and overall its entire communication system with Earth actively emits light. However, in strict radio silence mode, only thermal and re-emitted radiation are present.
Basically, you can pretty much do whatever you truly desire and want to do.
The question is why, for what purpose?
All right, next question. Is the 5,500 kilograms just the payload, or does that number include fuel, engines, and so on? No, that's just the payload. That's only the useful load you can carry.
With the Nova 02, when we say 500 kilo, that actually includes the entire gondola, which is supposedly made for passengers and piloted. So that includes the pilot and the whole gondola, and within that, you have 500 kilo. If it's a completely unmanned version, then the entire gondola is gone. It just becomes a motor gondola and a cargo trailer, where you can basically hang the cargo, so you can actually carry even more than 500 kilograms of weight.
Is it possible to install a wind turbine on a dirigible and transmit energy to the ground via a cable? I think I've seen some futuristic images like that somewhere.
The Chinese have recently built and are testing one. Once they release a report on its efficiency, or more likely, when they start mass producing such turbines as proof of their effectiveness, then we'll have a scientific answer about the applicability of these systems. Overall, for some specific mobile and low power generation scenarios, it's probably quite feasible and indeed a viable option. But there's really no practical point in attempting to send something exceptionally large and cumbersome like that particular apparatus up there.
Is there already a fully established facility for Nova 2 at the new airfield? No, of course not yet. The current plan is to build either an inflatable structure or...
The inflatable structure seems most logical, especially considering Nova 2 in its unmanned format as a monitoring airship interests the customer. The customer is interested not only in the airship itself, but also its designated parking, storage, and maintenance location. This pneumatic frame is being transported.
A simple solution, yes indeed, yes. How much exactly does a single cubic meter of helium truly cost, and how many cubic meters are precisely needed for the Nova 01 project? Helium has, in recent times, become much more expensive for everyday and general use. How does this significant development affect you and your operations?
The total cost for the entire refill, including the delivery process, the return of the empty cylinders, the rental fees, the initial deposit, and absolutely everything else associated with this transaction, ultimately came out to around 200,000 rubles. We successfully filled it with approximately 120 cubic meters of helium. That's about it, really.
So why exactly are you opening a pilot school? Why are they truly needed if a significant 90% of transportation will be automated?
Tourist vehicles, for example, those specifically designed for carrying numerous people, must always have qualified pilots on board. When large, scheduled airships eventually appear, experienced pilots will also be absolutely mandatory there, at the very least, so that a competent individual is simply sitting attentively at the controls. Cargo of a certain nature will require pilot escorts. That is, when it comes to especially sensitive or important cargo, not just anything. This will be a requirement, and in general,
Well, it certainly makes sense, right? It would be quite strange otherwise.
yes, building airships without pilots, without the need for training pilots. Of course, it's a very bold statement, and then the important question will inevitably arise. Do we already have a pilot training school?
Why are you opening a pilot school?
No, we're not opening a pilot school just yet. For now, we've only just begun developing the comprehensive training program. This program absolutely needs to be approved and accepted by Rosaviația, and any currently existing school can serve as the training center. There's truly no need to open a brand new one. It's just that once the program is approved, some school will be conditionally certified to train pilots. And there are already plenty of such schools, ranging from small to large. And there, 3 pilots who are essential for the coming year and beyond will undergo their comprehensive training. That's it. That's the entire pilot school. There's really nothing special that needs to be opened there. No need to build a large campus or anything like that. In fact, the simplicity of its operation is a key aspect. We're preparing the groundwork that will make it possible. For now, we're just preparing the procedure, because the actual established procedure for effectively training airship pilots does not yet fully exist. In the foreseeable future, of course, it will not just be a mere handful of individuals. Instead, there will be dozens of highly skilled pilots actively being trained and prepared. It will keep on growing and expanding, and who truly knows, maybe in the foreseeable future some of you will want to study. Perhaps you'll want your very own small personal cruise airship, wanting to fly with your beloved family. But what about the license? Sure, you can just get in, like with autopilot, press a button, but I think personal air transport like this is unlikely to be allowed without a license. Autopiloted passenger transport will be handled by large companies, but still, if it's some kind of private flying vehicle, most likely you'll need a pilot's license, even if it flies automatically, maybe a simplified one, because, as they often say, aviation regulations are truly written in blood. Yes, and no matter how incredibly safe it is, still, every single time we board a plane, even though people fly thousands of times, still there's always a safety briefing, the exit is here, life vests are there, if the mask drops, breathe through it. So nothing is done without reason, and even when you board a private plane, when you board, at the very least, you'll be given instructions on certain actions you need to take. In general, it's actually useful to read the manual before pressing any button, even for an oven, let alone for a dirigible. And ideally, you should check, did you read it or not? That most likely is what training is.
Great. What requirements will there be for these pilot students? What will the first intake look like? How many spots will there be?
Well, I've already generally and comprehensively explained what will happen at the very beginning of this process. Right now, the specific requirements for this project are still actively being developed and refined. Most likely, at first, this will be enough. Above average cognitive ability and the desire to become a pilot.
How will communication with the aircraft be effectively maintained in the challenging northern latitudes? In theory, the aircraft can be connected to Starlink, but unfortunately it's not yet available.
This is indeed one of the most interesting and crucial points about communication in general. Airships, yes, they can fly somewhere quite near mobile towers and stay connected, but as soon as they fly a bit further into the vast untamed wilderness, things get much tougher indeed. Satellite communication isn't solely limited to Starlink. There are, in fact, several distinct systems that can be effectively used for communication. The crucial question, of course, is precisely how much data they can truly transmit, and even conventional radio communication like VHF can be reliably used to send essential commands and valuable data as well. Well, obviously, in a somewhat limited capacity, specifically along certain established commercial routes, there will probably be some communication towers strategically set up. If by that time advanced stratospheric systems have fully developed, and it is highly anticipated that they definitely will in the foreseeable future, we'll then be able to efficiently create sophisticated relay stations on what are known as stratolites, which are essentially high-altitude platforms designed for this very purpose. Actually, there's a program now, at least in our country, yes. All this is specifically about our own country. If we were to go abroad, and there are about 190-something other countries, Starlink works there, so there won't be any problem at all whatsoever in those particular regions. But here, in our country, we'll have to get a bit creative and innovative. Right now, there's a specific program. I can't recall the precise official name, but it's something along the lines of Unified Sky or Integrated Airspace, where everything from high-altitude geostationary satellites orbiting far above the Earth, all the way down to small agile quadcopters flying just above the ground and even the grass, is intended to collectively create a vast, interconnected, and truly unified space for comprehensive data collection, efficient signal relay, seamless interaction between various entities, and many other related operational functions. And this comprehensive program includes the creation of all-encompassing and complete coverage over the entire territory of our country. Most likely, this will be achieved in part with the significant help of advanced stratospheric probes and innovative airships. So the question here isn't even about where the airship will find this connection, but rather how many airships are needed to provide coverage everywhere. It's actually a pretty cool piece of news. We discussed this and we stated right from the very beginning that this could be done, that it's possible, well, simply because it really is possible, of course. But when we actually started engaging in detailed discussions with the dedicated group involved in the truly innovative Unified Sky project, they, even without directly interacting with us or specifically considering our particular interest in the development of airships, still independently came to the firm conclusion that advanced aeronautical technology is absolutely necessary there. They were like, "It's truly great that someone is diligently working on this. You are indeed filling that very specific and crucial niche."
Another truly interesting question arises. Will there be any extensive testing of the distinct possibility of docking airships with each other, and for what practical purpose could that even be needed?
Who knows? Hypothetically speaking, it could potentially be utilized for transferring valuable cargo or even numerous passengers from one airship to another without ever touching the ground. If we really let our imaginations run wild, they could potentially assemble into protective clusters to wait out a severe storm, because together we are truly stronger, or dock together like a long train to travel in a precise formation, depending on the specific aerodynamics. You can experiment with this concept both in a theoretical, abstract, and physical mathematical space, and also in reality. However, how truly necessary and practically applicable this will actually prove to be in practice, no one can definitively predict right now, so we will have to wait and see.
How much do solar activity and atmospheric air pressure affect the flight characteristics of an airship?
Solar activity has virtually no significant effect. The only thing it definitely does is destroy the delicate soft envelope of airships with powerful ultraviolet light, which is precisely why they are carefully protected from harmful UV radiation. Heating significantly affects the expansion of helium. When it flies under the intense sun, it heats up considerably, the helium expands and consequently pushes the air out of the ballonet. And for example, in very hot weather conditions, it's a bit harder to ascend higher because with the gradual loss of pressure, it also expands further. But these are all relatively minor details. All of this fundamental understanding was thoroughly figured out over 100 years ago. Geomagnetic storms have absolutely no effect at all on this phenomenon. So, in general, there is indeed a noticeable effect. An airship is, in a very real way, a breathing organism, so to speak. But all these intricate patterns have been understood for a considerable length of time, and this deep understanding is exactly what truly distinguishes an experienced airship operator from a novice. It's the crucial fact that they inherently know what will predictably happen with a drop or rise in pressure, temperature, and so on and so forth. And all these air gas systems are thoughtfully designed with this in mind, with extensive experience, and just like 100 years ago, the fundamental principles haven't significantly changed. Pressure, temperature, the interplay of cold and heat. That's still precisely how they're designed today. If you pick up some truly interesting books about airships, somewhere in the middle you'll discover all these clever tricks and subtle nuances. In short, it's all been known for a very long time. Question: how does it profoundly affect things? In all sorts of diverse ways. Obviously, when it's significantly cold, everything tends to shrivel up or contract, and you absolutely have to manage all of that carefully, depending on altitude and other environmental factors. There's nothing overly complicated about this particular process.
As I understand it, these effects are already quite predictable and well understood.
Of course. Airship experts often share some truly interesting stories about their various experiments and the unexpected challenges they encountered. At one time, a large and specially constructed balloon was made for China, and it was then carefully kept in a closed hangar. I can't recall all the precise details exactly, but they left it unattended for a period, and the sun was shining directly on it, creating conditions that would ultimately lead to unforeseen consequences. They did something with the valves so that they absolutely would not leak. They meticulously tightened them, I guess. Yes, they carefully tightened them, and then, quite surprisingly, it just burst. That is to say, no additional gas was added, nothing else was done to it, it simply burst due to the intense heat. They say that when they came in the morning, it was completely gone. That's precisely how the sun's powerful rays affect amateur airships.
And here's a follow-up question. How many factors actually and truly affect the controllability of the craft, and to what extent are they precisely accounted for by the onboard computer? Wind, temperature, pressure, humidity, sunlight, air density, static electricity. Is that all? Or is there something else? That seems to cover the main ones.
The primary and most significant factor is indeed the wind. Everything else, in comparison, constitutes merely minor and insignificant details. Controllability factors. Static factors don't affect controllability. The air density at an altitude of 1 kilometer is one thing, but for it to really have an impact it needs to be at an altitude of about 4 or 5 kilometers, roughly speaking. Temperature doesn't affect it at all, so basically it's mainly wind and altitude, yes.
I have a quick question from me. Does a large cargo airship, for example, truly need to ascend to an altitude of around 10 kilometers, much like conventional airplanes typically do, where the air is significantly thinner in order to fly more efficiently, or is it entirely sufficient for it to fly at a lower altitude of just 1 or 2 kilometers?
Gennady, take a seat. 2 points for the question. The closer a cargo airship is to the ground, the more cargo it can carry. If it's a cargo airship, it doesn't need to go up that high. But if it's a high-speed airship and we're willing to sacrifice, say, some cargo capacity, it will carry much less up there. However, there's also less air resistance at that altitude, so it can fly at higher speeds. That's precisely the niche that aerostats will be targeting in the future.
By eliminating aerodynamics?
Yes, and focusing on the speed of things.
Alright, next question. What is the production cost of building a single airship with a 10-ton payload capacity in a batch of 1,000 units? At least approximately, what order of magnitude are we talking about at the current exchange rate, assuming everything is ready to launch such a production run? How many tons? 10 tons, a batch of 1,000 units? I understand it's a rather complicated question with many unknown variables, but please try your best to provide an estimated figure. What would be the approximate production cost of building a single large airship with a substantial 10-ton payload capacity when manufactured in a significant batch of 1,000 units?
It is less than 1 billion rubles per unit, a figure that represents a significant investment. I genuinely cannot provide a more precise or exact figure at this particular moment.
Just roughly speaking, without providing exact numbers.
I don't think it's necessary, no. Well, a batch of 1,000 units that can be made quite cheaply. A 10-tonner.
10 tons, that's our Nova 35.
Yes, let's consider the cost of a helicopter that possesses the impressive capability to lift a substantial weight of 10 tons. And then we would probably need to divide that cost by 2.
I certainly think so, yes, that is correct.
That would be the estimated cost price with some ideal, well-established production. But I understand that it will fly much farther than a conventional helicopter, be significantly more stable, considerably more efficient. Its operational range will be truly enormous. Cutting the price in half is, of course, a bold claim now that I think about it.
Yeah, as I look at it, it still doesn't quite... Alright, let's move on to another very interesting question. I want the airship to start flying over Russian cities. Where exactly is that even possible? I mean, today's current reality, a flood of photos will spread through local chats. When it's flying right above you, it's a completely different and truly unique experience. I fully support this, and I wholeheartedly share your desire and ambition to see airships over Russia.
Yes, we'll be flying over all the major cities, just gradually. At first, it'll probably be some rather remote regions, something like the significant city of Tomsk, or perhaps even somewhere deep within Yakutia, a vast and expansive territory. Yes, and the more frequently we fly and the more reliably we appear in the eyes of various aviation authorities, the closer and closer we'll ultimately get to the major cities. It's quite interesting, isn't it, these rather tricky cities? You absolutely cannot fly directly over Moscow, but you can certainly fly there. What exactly is so fundamentally different about those particular places? I genuinely don't quite get it. In Tomsk, they have created a special zone for conditional experimental unmanned large cargo vehicles, and most likely these kinds of zones will be the first places where flights of large commercial cargo drones will be permitted. Then, as the experimental trial periods pass and these vehicles are reclassified from experimental to regular use, they will surely be flying everywhere.
Everything in its own time.
Question, when or where precisely?
I'm just stating a simple fact. I truly want airships to start flying in the skies.
We are doing absolutely everything for that, and so are you, so it will certainly happen very soon indeed.
Yes, we're steadily moving toward those important goals. Is there any clear understanding of which specific country would be easier to successfully launch cargo transportation in, from a legal and regulatory standpoint? It might indeed turn out that the very first cargo shipments will be launched not within Russia, but rather in another country entirely. Honestly, I would genuinely like to see Russia be the absolute first in terms of the speed of implementing various large-scale technological concepts and advancements, but that's currently China.
China has just officially announced that several of its prominent provinces have now legally allowed the widespread use of fully autonomous, driverless taxis for public passenger transportation services. That's it. It's an experimental legal zone. Go ahead and operate. The rest of the world is now scrambling to rapidly catch up with the significant advancements made by China, so the definitive answer to the pressing question is, most likely, it's unequivocally China. Next are the Arab countries, which also very much want to be at the absolute forefront of global affairs, and they're not as inert or inactive as, say, the United States, which also is a significant technological powerhouse, but there is considerably more bureaucracy present there. So after that, it will probably be the Arab nations, then China. However, Russia, actually, while many people are discussing other countries, in Russia it will most likely take a considerably longer period of time. No, we have a lot of positive and significant changes taking place, and there are also these very important and specific special legal zones, such as the prominent Tomsk region, and various special economic zones, which are now in the process of acquiring and establishing their very own advanced federal flight test complexes, designed for comprehensive testing and development. And now, legislation and lawmaking have also significantly shifted towards describing a new type of aircraft, and in general have started to address the airspace as a whole, so overall.
Why not? I can clearly see a very clear interest, even in some official documents that popped up in our chats at the very beginning, directly from the government of the Russian Federation.
There are many promising directions for future development, and among these, airships are certainly a very significant one. The client we're currently working with is also from Russia, specifically focused on cargo transportation, and operating from that very important region. This is practically already written into the roadmap, so in Russia it's a top priority. But right now the Chinese are the only ones with a certified type of device. They have a dirigible, so it's the Chinese.
They're also well ahead of the rest of the world. So my next important question for you is, good evening, how do you plan to effectively deal with the potential issue of icing if you truly intend to fly in the northern regions? And what about an innovative airship powered only by batteries with a hull meticulously made of solar panels? These are indeed two distinct questions in one inquiry.
Gentlemen, you're already making me get quite sarcastic. Oh my god, could there really be significant icing? How could we not have possibly thought of that? There's absolutely nothing to worry about with icing. This particular issue was completely solved 100 years ago. Modern airplanes deal with it now. Specifically, how are we going to plan this? We have a power unit that will be installed and it generates a lot of heat. Not in the sense of heat like an ice engine, for example, which heats up a local area a lot, and it's hard to get rid of that heat. Here, it's not as intense, but there are large volumes of air, and these large volumes of warm air, warm enough for the icing issue, though still cold for the shell and other parts, handle the icing problem just fine. Plus, there are also many modern materials available. There are special advanced threads that can be intricately sewn into the very fabric of the shell or the outer covering, which will then effectively heat up. And yes, if the airship is rigid and already covered in solar panels, the panels themselves can heat up. This also isn't really a problem when it comes to electricity. It's as if the heat is generated on board or by these same panels. So, to answer the question briefly about how we plan to deal with icing by using heat.
Understood. If the control of unmanned airships is designed to be remote, how will protection against control interception, hijacking, and hacker attacks be ensured? Please tell us what measures will be taken. I hope the protection will be of high quality. How exactly will it be ensured?
Naturally, at this present moment, we do not currently possess a dedicated team working specifically on software protection, primarily because it is quite time-consuming, rather expensive, and not particularly important or crucial at this juncture. For the time being, having highly skilled hands and a very solid foundational understanding to commence programming from is entirely sufficient to adequately protect everything. Later on, specialized teams, specifically focused on comprehensive IT security, will certainly get involved because at that critical point, it will be truly impossible to proceed effectively without their essential and expert assistance. I could start with crypto encryption, but in reality, specialized companies handle this, so let's discuss collaboration.
For those who handle security and software protection, it simply makes much more practical sense to consistently turn to experienced experts in this specialized field.
Yes, in this modern 21st century, as someone thoughtfully mentioned in a comment under one of our recent posts or videos, it has already become an absolute necessity to turn to such specialized companies. Indeed, things have truly advanced so far that attempting to protect yourself completely from scratch is simply and utterly unrealistic. So yes, these are large, dedicated teams of people who carry out all this work calmly, following clear processes and transparent pricing. Even very large and prominent companies like the well-known airline AEROFLOT, for example, were recently subjected to significant and widespread cyber attacks, demonstrating that even major corporations, even those that specifically specialize in robust cybersecurity protection, still unfortunately encounter such disruptive security incidents. We will do our absolute best to prevent similar occurrences. With the right skills, you can control any system. Did you see the news? It was absurd. I read it and marked it on my calendar as something that happened. This was the first powerful info statement I read that truly surprised me. Some hackers gained access to information that supposedly included launch codes for France's nuclear submarine missiles. A significant amount of highly sensitive technical information and so on. Just imagine the profound implications. Malicious hackers gained unauthorized access to top-level military secrets, critical data on nuclear missiles, France's advanced submarines, and then this entire vast archive was suddenly leaked all over the public internet. We really do live in truly interesting and dynamic times. Yes, it is evident that states often turn out to be so remarkably inert, and no matter how diligently and persistently they try to stay at the absolute cutting edge of technology, their established processes and so on, there's always a distinct group that isn't bound by this inherent inertia, and they inevitably get access to new advancements and opportunities. We should reach out to those hackers and ask them to help us create anti-theft protection for the airship.
After purchasing the airfield, will there be a subsequent transition to the third or later stages of its development?
Well, I think everything is going entirely according to our established schedule. We've adopted a certain operational model, so to speak, and we are diligently following it. We only very recently switched stages. After purchasing the airfield, there simply won't be another stage change, so please do not expect it.
So, which specific starter generator system will be effectively utilized in the gas turbine unit? Will it be an asynchronous machine or perhaps a BLDC? By the way, here's a valuable suggestion: to vertically suspend the entire aeroplane above the test stand. That was an interesting idea we had conceived.
Yes, the ceiling height there is 6 meters. That's not the ceiling itself, but the maximum stand height. The ceiling is huge, but according to regulations, you can't go above 6 meters.
So it won't work, but it's a good idea.
A small model placed diagonally would be longer, maybe a few meters. Well, that would be about 6 or 7 meters, which should work.
Will there be developed permanent mooring points that the airship itself could effectively drop and then, after approximately half an hour of careful deployment, dock to by itself?
Well, that would mean that initially some kind of specialized technical airship would fly out and carefully drop these essential mooring points, right? And then a subsequent tourist or cargo airship would follow after it. Theoretically, it is indeed quite possible, yes. In theory, the airship itself could even carry its own dedicated mooring mast, and some airships have successfully done that before, so why not consider this as a viable option?
Can an airship become a fire engine or be used to fight forest fires? After all, if an airship suddenly drops tens of tons of water, it will shoot upward like a cork.
If it's an airship with enhanced hybrid capabilities, then it won't be able to take off, but in that case, should it put out fires like an airplane? Although it could loiter while maintaining aerodynamic lift, for example, and use directed jets, why not? In general, there are all sorts of possibilities, up to and including using some other methods. It's possible. The answer is yes, there are various concepts. Each one requires a deep dive. These are separate projects. For now, we're focused on developing the carrier itself, and what kind of payload is truly possible there. All sorts of different things is the very next step. When it comes to specialized firefighting equipment, it's not just about simply scooping up water and then dumping it, although that is certainly done, and it is indeed possible, but those are separate, highly targeted developments. There are a ton of various different solutions and innovative concepts for how to effectively use airships in firefighting with specialized bombs, with precisely controlled streams, and all sorts of other effective methods.
Naturally, everything requires thorough development and testing and so on. That's a separate topic, so it's something that can be worked on. Can a projector be used at the exhibition? Project your airship onto the ceiling. If it's flat, it will be visible from afar, just like it's flying above everyone.
You could potentially use this idea in a sort of pirate way. Just bring in a powerful enough projector and project an airship across the entire ceiling, as if it's gracefully floating under the exhibition. It would have to be a really truly powerful projector, because it's going to be super bright in there. Or perhaps you could even ask the hackers to cut the power.
But who would actually do that? There's only one company with airships? At the entire exhibition, just one single company with airships? No, it would clearly say AERONOVA right on it. If in the year 2028 there's a truly magnificent round-the-world flight on our impressive airship and the route goes through Los Angeles, I would really love to book a ticket to Russia well in advance. I truly dream of taking a flight like that. It would be an incredible experience.
Book out.
From Los Angeles all the way to Russia. He truly wants to go back home. Everything is already booked. I will personally reserve everything. For the clients of Nova 01, a formal contract has been signed or there are preliminary agreements in place.
Working groups have been successfully created. We are actively shaping the technical concept. I think that's a bit more than just a simple contract, so everything is perfectly fine. I'll also add that there is actually more than one important client.
Yes. So, how incredibly resistant is this airship to potential terrorist attacks? For example, is the well-known and widely utilized FPV drone a truly serious threat? Or would the airship be able to continue flying effectively, even with very large and significant holes in its structure?
Land safely. However, even heavily armored tanks aren't entirely protected from the increasingly prevalent and highly effective FPV drones, so there's that significant concern. People often say, with a powerful grenade launcher, with a rapid-firing machine gun, virtually anything can be damaged. A huge airship? It's unlikely that an FPV drone could damage it enough to cause a disaster. It would calmly descend, and nothing terrible would happen, unless it hits the cockpit where someone is. Obviously, in that case, there would be consequences. A small one, though, would of course be significantly affected by any powerful explosion. If you truly need an anti-terrorist airship so that it can launch its own FPV drones to intercept, organizing that isn't particularly difficult.
Well, you could just put the spoon in, right?
Yes, the airship, since it is well equipped with energy and has great lifting capacity, can actually carry a lot with it against various mechanisms, though I don't want to say weaponry. You can do absolutely anything you set your mind to. Well, on that truly positive and encouraging note, the questions have finally come to a complete end, my dear friends. If you have any more pressing questions, please feel free to ask them, and we will certainly show you the way. If you are a valued client and most likely drive a heavily armored vehicle and possess the significant means to create a specially protected airship, please give us a discreet wink. We will meticulously develop one just for your specific needs.
So, well, it looks like that's all the questions for now. I'll quickly go through them one more time, and if there aren't any new ones, we'll wrap up. Overall, our webinar has already been going for an hour and a half.
Let me take a look. There are all sorts of different news, of course, but that's enough. I'm reading here. We are actively adopting all sorts of different internal standards and comprehensive guidelines, meticulously changing various organizational processes and refining established procedures, and diligently starting entirely new developments in close collaboration with production teams. Everything is actually moving along, but in the last webinar I explained where things stand. By next Thursday I can give an update on the statuses, so we'll gather some news about production and assembly.
Well, then we'll prepare them for the next webinar.
It would be better if the volume was higher, someone wrote in the chat at the very beginning.
Guys, I think we really fixed it.
Great, well, that's all for now, my dear friends. Stay tuned for important updates, and please do look out for the highly anticipated upcoming video about the fascinating laboratory. New and exciting videos will be released very soon. Although we commonly refer to it as the laboratory, in actual fact, the specific division within our organization that we are currently designating as the laboratory is presently operating and functioning as a fully fledged pilot production facility, actively engaged in the initial stages of manufacturing and development right now. For example, in Lyubertsy at Ruslan's place, they have a very well-equipped and specialized mechanical workshop there where they meticulously create the robust structural frames for the entire tail assembly, and that's all truly excellent and remarkably well executed. And for example, small intricate devices, complex circuit boards, robust power supply systems, the sophisticated onboard computer, and various small rotary mechanisms and so on. All of that is meticulously made right here, of course. So it's not really just a laboratory, I don't even know. It's more like a small, highly efficient pilot production facility, and at the very same time, a comprehensive laboratory. And there are updates there as well, of course. Those who have been following saw what Artyom was working on at the very beginning and heard him say, "We'll launch everything soon." Well, finally, that soon has arrived. It's been a long time coming. So, you can expect some new videos coming your way. We are starting the science branch of our content. Hopefully, it will be quite active and engaging. Is the material being prepared? Yes, stay tuned. It's going to be interesting. Alright, goodbye everyone.
Thank you. Leave your feedback.